Hi everyone, in this video we'll go through concepts on maxima and minima along with examples. What is maxima and minima of a function? Look at this particular graph. Say there are 3 points here. One is point A, and then there is one point which is on the left hand side of A and one point which is on the right hand side of A. So basically between this interval, in this interval you have one point A which is having the maximum value. Let's consider the interval as the end point of the interval is a minus h, and another end point of the interval is a plus h. So there is some point A on this particular curve. There is some point A on this curve which is having a maximum value. So you take any number of points in this interval, any number of points. When you substitute these points in the function, say x plus a, x plus b, any function, when you take any values on this particular curve and substitute in this function, you will see that those values will be less than this particular point. Say x is equal to a. So basically there is some point, this entire curve, which is bigger than all the other neighboring values. Similarly, for minima, you will have a curve like this. Say there is one point here, a. This is at x is equal to a, right? And say this is the end point of the curve. So you will find in this entire curve, there will be one point which will be minimum or smallest of all the other points. Now, given a problem, how do we find maxima and minima? You'll have to find double derivative, second order derivative. You have to differentiate twice. When you differentiate twice, if you get the value greater than 0, then the function at that particular point is minimum. Then you can say function is minimum. Similarly, if you get less than 0, then function is maximum. If it is equal to 0, then function is neither maximum nor minimum. And the point at which this double derivative becomes 0 is called as point of inflection. So notice one thing, it's reverse here. Greater than 0 is minimum, less than 0 is maximum, is equal to 0 is neither maximum nor minimum. So remember this reverse logic. Greater, minimum, lesser, maximum. Whenever there is a problem, finding maxima or minima is a 4-step approach. You have 4 steps here. First, you'll have to find dy by dx. That is a first order derivative. Then put that dy by dx as 0 and get the values of x. Then differentiate again. That is find second order derivative, d square y by dx square. And then see the value that you get after finding second order derivative. If it is greater than 0, then you can say the function is minimum. If it is lesser than 0, then function is maximum. If it is equal to 0, the function is neither maximum nor minimum. Once you know the x values and once you know if it is maximum or minimum, then take the x values and substitute in the main function, what is given in the problem. Substitute there so that you get the actual maximum value or minimum value. You need to get the value, right? So that value can be obtained by substituting the x values in the function. So let's take an example. Find the maximum and minimum value of the following function. So what is step 1? We'll have to differentiate. We'll have to find dy by dx. So dy by dx, or I can write as f dash of x is equal to 12 into 5 into x over 4 minus 45 into 4 into x cube plus 40 into 3 into x square plus 0. So this is nothing but 60 x power 4 minus 180 x power cube plus 120 x square. So let me take common factor minus 3x cube plus 2x square. Now step 2. What is step 2? Put dy by dx as 0. We'll get 0 is equal to 60 into, we'll copy this thing. So when I transfer 60 here, it's going to be 0 only. So I'll get 0 is equal to this entire expression. So I'll take x square as common. I'll get x square minus 3x plus 2. So this is a quadratic equation. I can find the factors. So x square minus 3x plus 2. I'll use sum product method. So you have to take two numbers, number 1 and number 2. If I add them, I should get minus 3. And if I multiply, I should get plus 2. So if I multiply, I should get 2. If I add, I should get minus 3. So what can be the numbers? Numbers can be 2 and 1. Right? I have to get 2 plus 1 is 3, but I want minus 3. So I'll put minus on both sides. So I'll get minus 2 minus 1 is minus 3. Minus 2 into minus 1 is plus 2. So numbers are x minus 2 and x minus 1. So I can write this as x minus 2 and x minus 1 equal to 0. This means that x square is equal to 0, x minus 2 is equal to 0, x minus 1 is equal to 0, which means x is equal to 0, x is equal to 2, and x is equal to 1. So these are the values of x. Now what is step 3? Step 3 is double differentiate. So d square y by dx square is equal to, so if I double differentiate this, I'll get 4x cube minus 3 into x square plus 2 into 2 into x, which is 64x cube minus 9x square plus 4x. Now what I have to do? Now I have to find out if the function is maximum or minimum. What do I have to do for this? I have to substitute values of x in d square by dx square in double derivative. We got 3 values of x. We got 0, 2 and 1. At x is equal to 0, x is equal to 2, x is equal to 1. So at these 3 values we'll find d square by dx square. So 60 into 4x cube minus 9x square plus 4x. So here I'll substitute 0. When I put 0, it's going to become 0. Entire thing is going to become 0. Since this is 0, we can say f of x is neither maximum nor minimum. Now we'll take at x is equal to 2. At x is equal to 2, we'll get 60 into 4 into 2 cube minus 9 into 2 square plus 4 into 2. That's going to be 60 into 32 minus 36 plus 8. So this is going to be greater than 0. You don't have to completely get the calculation done. If it is greater than 0, you can stop it. Since it's greater than 0, you can say this function is minimum at x is equal to 2. So remember the reverse logic here. If it's greater than 0, then function is said to be minimum. Now we'll do the same thing at x is equal to 1, right? I'll write this double derivative. You can write either d square y by dx square or f double dash of x. Now I'll substitute 1. So 4 into 1 minus 9 into 1 plus 4 into 1. So I'll get 16, 4 minus 9 plus 4. So now if you notice, this is going to give me minus 1. 60 into minus 1. So it's going to be minus. I'll get some minus value, right? This means it's less than 0. Since it is less than 0, I can say f of x is maximum at x is equal to 1. Now we figured out at what values of x it is maximum, minimum or neither. Now what is the last step? Step 4. Step 4, we have to find maximum value, minimum value. At x is equal to 1, we get max value. At x is equal to 1, we get max value, right? And what we have to do? We have to substitute x value in f of x. So you have to take the original function. What is the original function? Given in the problem, this one. We have to take this function and substitute x value. So now you substitute x value. So we'll put x as 1. So I'll get 12 minus 45 plus 40 plus 6, which is 13. So 13 is the maximum value at x is equal to 1. So this is one answer. Now we'll have to find at x is equal to 2. At x is equal to 2, function is minimum. So we'll have to find minimum value. Minimum value is equal to, when you substitute, I'll substitute 2 here. So 12 to the power 5, 45 into 2 to the power 4 plus 40 into 2 to the power 3 plus 6. So this will give me 12 into 32 minus 45 into 16 plus 40 into 8 plus 6, which is 384 minus 45 into 16, 720 plus 320 plus 6, get minus 10. So I'll get minus 10 at x is equal to 2. So here's the answer for this problem. Now let's take another problem where we have to find the maximum and minimum value. So step 1 is differentiate and find dy by dx. So this will be 4x cube minus 62 into 2 into x plus 120 plus 0, which is 4x cube minus 62 is 124x plus 120. Now let me take common. So I'll get x cube minus 31x plus 30. Now step 2 is put dy by dx as 0. So I'll get 0 is equal to 4 into x cube minus 31x plus 30. So if I shift 4 here, 0 by 4 is going to become 0. So I'll get x cube minus 31x plus 30. Now how do I find x values? Because this is cubic function. How do I find x values for cubic function? You have to take this constant. What is the constant? You have to take the value which has only number, no x in it. It's 30, right? Constant, you have to take constant value, which is 30 here, right? The one which has only number, no x in it. So constant value is 30. Now I need to find factors of 30. Factors of 30. So what are the factors of 30? 1, 2. In 2 tables you get 30. In 3 tables, in 5 tables, 6 tables, then 10 tables, 15 tables and 30. So these are the factors of 30. So now I can take each of these values, substitute here, and if I get it equal to 0, then that becomes one of the x values. So say I'll start with x is equal to 1, right? X is equal to 1, it will be 0 is equal to, I'll substitute here. Let me write this equation first. So I'll write this equation first. Now I'll put at x is equal to 1. This is the way to find roots when you have cubic function. At x is equal to 1, it will become 1 minus 31 plus 30. This is equal to 0. 31 minus 30. So this is one of the roots. This is one of the roots. Now we'll go ahead with the next one. X is equal to 2. If I put x is equal to 2, I'll get 2 cube minus 31 into 2 plus 30. I'll get, this is not equal to 0 if I calculate. So this is not the root. Now I'll go with x is equal to 3. 3 cube minus 31 into 3 plus 30. This is also not equal to 0. Then I'll go to x is equal to 5. 5 cube minus 31 into 5 plus 30. Here I'll get 25, 125 minus 155 plus 30. So this is equal to 0. That means this is the next factor. So we got two x values. X is equal to 1 and 5. Since it's a cubic function, we need to get 3 values of x. So we need to find another value of x. Let's continue. X is equal to 6. It basically 6 cube minus 31 into 6 plus 30. So this will be 216 minus 186 plus 30. Is this equal to 0? This is not equal to 0. But there is something here. If it was minus here, then it would be equal to 0. That means if it has to become minus here, then it could be minus 6. Probably when x is equal to minus 6, I'll get this. See? So when x is minus 6, I'll get minus 6 the whole cube minus 31 into minus 6 plus 30. This is going to be minus 216 plus 186 plus 30. So now you see 186 plus 30 is 216. 216 minus 216 is 0. So then another root is minus 6. So another value for x is minus 6. Now this is one way. So it might be difficult sometimes, right, for us to understand that probably have to put a negative sign. So the other way is, what you can do is, you've already received 2 roots, right? So you'll have to write it like this, x minus 1 and x minus 5. We've got the roots like this, x. You'll have to shift 1 this side. Say x is equal to 1. When I shift 1 this side, it will become x minus 1 is equal to 0. Similarly here x is equal to 5. So if I shift 5 this side, plus 5 will become minus 5 and I'll get 0. So these are the two factors I have. Now what I'll do is, I'll write it like this. X minus 1 and x minus 5. I'll multiply this. When I multiply, I'll get this, which is nothing x square minus 6x plus 5. This is what I get when I multiply, right? Now what I'll have to do, I'll have to use a division method to get the other root. That is, I'll have to use a division method and take this expression, x cube minus 31x plus 30. Now I'll find the quotient here. I have to multiply x square with x so that I get x cube, right? So then minus 6x into x is minus 6x square. 5 into x is 5x. Now let me subtract this. So this will get cancelled. I'll get minus 6x square plus 6x square, minus and minus, 31x. So I'll get minus 36x plus 30. I'm getting this down. Now I'll continue with division. I have to multiply x square with plus 6. Then only I'll get 6x square. So I'll get 6x square. 6 into minus 6 is minus 36x. 6 into 5 is plus 30. Now I'll subtract. This will get cancelled. This will get cancelled. This will get cancelled. I left with 0. So remainder is 0. So what did I get here? X plus 6. So this is my next factor. X plus 6. So now we have three factors here, right? X minus 1, x minus 5 and x plus 6. When I equate each of these to 0, I'll get x is equal to 1, x is equal to 5 and x is equal to, when I shift 6 this side, what will happen? Minus 6. So x is equal to minus 6. So basically I'm taking x minus 1 is equal to 0, x minus 5 is equal to 0, x plus 6 is equal to 0. So x becomes 1, x becomes 5 and x becomes minus 6. So 1, 5 and minus 6 are the values. So this is what we got here also, 1, 5 and minus 6. Now we know the x values, right? So let's go to step 3. What is step 3? Double differentiate, right? Double differentiate. So you have to find d square by dx square or f double dash of x. So f double dash of x, let's take the first order derivative, this one. So now I'll differentiate this again. So I'll get 3x square minus 31, right? Simple. Now I'll have to figure out max minimum. I have to find out if the function is maximum or minimum or neither. And now what should I do for that? I have to substitute x values in double derivative, second order derivative, right? I have to substitute. Let's take first one. At x is equal to, what are the values? 1, 5, 6. 1, x is equal to 5, x is equal to 6. I'll have to find f double dash of x is equal to 3x square minus 31. 3x square minus 31. So 3 into 1 minus 31, which is minus. So I don't have to get the actual number. It's minus some number. So it will be less than 0, which means it is maximum at x is equal to 1. Now I'll find at x is equal to 5. At x is equal to 5, it will be 3 into 5 square minus 31, which is 25 into 3, 75 minus 31. Obviously, it's greater than 0. It will be minimum at x is equal to 5. Greater than 0, so minimum at x is equal to 5. This is less than 0, so maximum at x is equal to 1. At x is equal to 6, we'll get 3 into 6 square minus 31, which is 108 minus 31. Again, this number is going to be greater than 0, which means it minimum at x is equal to 6. Oh, it is x is equal to minus 6. I forgot to put minus. Anyway, even if I put minus 6 square is plus only. So it is minimum at x is equal to minus 6 because it's greater than 0. So now we have figured out if the function is minimum, maximum. Now we'll have to go to step 4. What is step 4? Last step. Find out value. Find out maximum and minimum value. Now whatever we did here is only to find out at what point is the function maximum and at what point is the function minimum. So we found that at x is equal to 1 it's maximum, at x is equal to 5 and minus 6 it is minimum. Now we need to find the actual value, right? We need to find the actual value, and that for that you need to substitute in the original function, that is f of x. You have to substitute here. At x is equal to 1 we get maximum value. F of x is equal to 1 minus 62 plus 120 plus 9, you get 68. The maximum value is 68. Now I'll find x at x is equal to 5. At x is equal to 5 it's minimum. So minimum value, so I'll substitute 5 to the power 4 minus 62 into 5 square plus 120 into 5 plus 9, I'll get minus 316. Now I'll find at x is equal to minus 6. This is also minimum value, right? X is equal to minus 6 is also minimum. So minimum value is minus 6 to the power 4 minus 62 into minus 6 square plus 120 into minus 6 plus 9. So I'll get, on calculation I will get minus 1647. So this is minimum value. So remember, minimum value will be a negative sign and the maximum value will be a positive sign. Now let's solve a different kind of a problem where the sum of two natural numbers are given and the product is given to be maximum. We need to find the numbers, right? We need to find what these numbers are. So two natural numbers are there. Sum of those two natural numbers, that is when you add these two numbers you get 48, and product, and their product is maximum. That is when you multiply these two numbers, the product is having a maximum value when you multiply these numbers, right? Now we'll have to find these natural numbers. So we assume that the two numbers are x and y, right? So x plus y is 48. Sum x plus y is 48. Product means x into y. X into y is, say, p. Now what does it mean when we say product is maximum? It means d square p by dx square is less than 0. Since it is maximum, the double derivative, the second order derivative should be less than 0 since it is maximum, which means we'll have to find double derivative now. First we'll find single derivative of this. So you take p is equal to x into y. Now we don't want y here, we just want everything in terms of x. So instead of y I can put x plus y is 48. So what is y? Y is 48 minus x. So instead of y I'll put 48 minus x, right? This is actually x into y. So I'll put 48 minus x into x. So when I solve this I'll get 48x minus x square. Now I'll find first order derivative dp by dx, right? So it will be 48 minus 2x. Now I'll put 0, right? I'll equate the first order derivative to 0. Find the value of x. So I got the value of x, right? So x is 24. That means this is the first number. First number is 24. So we assume that the two numbers are x and y. First number is 24. Now we'll have to find the second number. It is actually very simple. Second number is, sum of two numbers is 48. Second number will be 48 minus 24, which is 24. Second number also will be 24. Both the numbers will be 24. Now only thing is, since the product is maximum, we just have to verify the step that it is maximum. We just have to verify. So what you will do, you'll find double derivative, second order derivative of this function, right? You'll find you'll differentiate this function again. So I'll get minus 2. When I differentiate, I'll get minus 2, which is less than 0. Since it is less than 0, the function is maximum. So they've told it is maximum. We have verified that it is maximum. And the two numbers are 24 and 24. That's all. Let's take another problem. Find two positive numbers whose sum is 14. Again, when you add these two numbers, it's 14. And the sum of whose square is minimum. Sum of squares is minimum. Let's solve this. Let the two numbers be x and y. And when you add these numbers, you get 14. Sum of the squares. Sum of their squares means x square plus y square. Square of this, sum. Sum means add them. When you add them, it is minimum. Right? Now, let's call this as, say, S. Right? We'll call this as S. And this is minimum. the sum of these. When you total up this, it becomes minimum. Now what is the rule for minimum? D square, double derivative should be greater than 0 to prove that it is minimum. Right? We'll try to get the second order derivative. For that, what is step 1? What is step 1? We'll have to differentiate once. Right? But we have to differentiate s. So instead of y, I'll put s because I'm going to differentiate s here. Right? So before this, let's substitute y. Let's not forget this. Let's substitute y. I can say y is equal to 14 minus x. Right? So I can say y is equal to 14 minus x. So I'll write x square plus 14 minus x the whole square. Instead of y, I put 14 minus x. X square plus, when I expand this, 14 square is 196 plus x square minus 28x. So when I expand this, I'll get this. Step 1 is to find dy by dx. So I'll find ds by dx is equal to 2x. So it will be 4x minus 28. I'll have to equate this to 0. Right? So if I equate this to 0, I'll get x is equal to 28 by 4. I'll get x is equal to 7. X is one number. X is 7. The other number should be 14 minus 7, right? Because it's x plus y. X plus y is equal to 14. X is equal to 7. Therefore, y will be 14 minus 7, which is 7. Y is also 7. So we got both the numbers. And we'll just do one more step to verify that the sum of squares is minimum. We'll find the double order derivative for this. We'll differentiate this again. So we'll get double order derivative, which is 4. 4x minus 28. So derivative of 4x is 4. This is greater than 0. That means it's minimum. Right? Since it's greater than 0, it is minimum. That's what they've told. It's minimum here. So we just verified. Let's take another problem. Find two positive numbers whose sum is 30. Sum of their cubes are minimum. So two positive numbers. Let's assume that two positive numbers are x and y. When you add them, you'll get 30. And then there is sum of their cubes. Cubes means to the power 3. So x cube plus y cube. The sum of the cubes. That is when you add the cubed numbers. When I cube x and when I cube y. And when I add them, it should be minimum. Minimum means second order derivative should be greater than 0. Right? This indicates it's minimum. Now I'll take that the sum is s. Right? So now first eliminate y. Instead of y, we can write as y is equal to 30 minus x. Substitute 30 minus x here. So when I expand this, so there is a formula, right? The formula is whenever you have a minus b the whole cube, this form a minus b the whole cube. Whenever you have it like this, the formula is a cube minus b cube minus 3a square b plus 3ab square. This is the formula. If you can't remember the formula, multiply this and then again multiply this. So you'll get this entire expansion. Now you can find first order derivative. So when I put the first derivative as 0, I'll get the value of x. X is equal to 15. So I got the first number. First number is 15. The other number also has to be 15. Because 15 plus 15 is 30. Right? So the other number also will be 15. Now I just have to verify that the sum of cubes is minimum. That means I have to take double derivative. So I'll take this first order derivative. Differentiate this again. So when I differentiate, I'll get 180. 180 is greater than 0. Therefore, greater than 0, therefore it is minimum. So that's what they've given. It's minimum. So we've proved that. Let's solve another problem. The product of two natural numbers is 64. Find the numbers if their sum is minimum. Let numbers be x and y. Product of two natural numbers. Product means multiplication. Right? That is x into y is 64. Find the numbers if their sum is minimum. Now, sum means add. So when x plus y is equal to, it's minimum. Right? So I can say s is equal to x plus y. Minimum means double derivative is greater than 0. Right? Now let's eliminate y. Right? What will I put instead of y? I'll say y is equal to 64 by x. X into y is 64. Therefore y is 64. I'll bring x this side. So it will become 64 by x. So I'll write this as x plus 64 by x. Now I'll go to step 1. Step 1 is differentiate ds by dx. Dx is equal to, let me differentiate this. Derivative of x is 1. Put the number outside. So you are left with 1 by x. What is derivative of 1 by x? It is minus 1 by x square. Derivative of 1 by x is minus 1 by x square. This is nothing but 1 plus 64 by x square. It's minus. So this is ds by dx. Now I'll equate this to 0. So I'll get 1 minus 64 by x square. I'll shift 1 this side. So it will become minus 1 is equal to minus 64 by x square. Minus and minus will get cancelled. So I'll get, and I'll shift x square this side. This is under division. So when I shift, it will become multiplication. X square into 1. Since this is the denominator, this will go, when it goes to the other side, it will come to the numerator. So x square into 1 is x square is equal to 64. X square is equal to 64 means x is equal to square root of 64. So whenever there is square root, it can be plus or minus 8. Square root of 64 is 8. It can be plus 8 or minus 8. Now I've got one number. X is one of the numbers. They've told product. What is product? Product of x and y, that is x into y. Product of x into y is 64. If x into y is 64, I know the value of x. X is 8. 8 into y is 64. Which means y is equal to 64 by 8. Which means y is equal to 8. So y is also equal to 8. And x is also 8. Right? So we've got both the numbers. Now we just have to do the last step. We'll have to verify that it is minimum. So we'll have to find second order derivative. Now you differentiate again. So when I differentiate this, I'm differentiating ds by dx, which is 1 minus 64 by x square. So if I differentiate this again, I'll get d square s by dx square is equal to, derivative of 1 is 0, minus 64. Derivative of x square, I can write it as x to the power minus 2. Right? When I shift x on top, what will happen? Here it's plus 2, it will become minus 2. Basically, it will become x to the power of minus 2. It will become minus 64 into x to the power minus 2. Now I'll use the formula. Derivative of x to the power n is equal to n into x to the power n minus 1. So instead of n, I have minus 2. So I'll get minus 2 into x to the power minus 2 minus 1, which is minus 3. So you can write this minus 64 into minus 2 into x to the power minus 3. You can write this as minus 64. Minus and minus will become plus. 64 into 2. I can bring x down. When I bring x down, it will become, instead of minus 3, it will become plus 3. So it will be 128 by x cube. If I have to figure out its maximum and minimum, I'll substitute x here. What is the value of x we got? We got 8. So put x is equal to 8. So I'll get double derivative as 128 by 8 cube, which is 128 by 512. Now this number is going to be greater than 0. Because it's a positive number, when you divide, I'll get 0 point something, which is greater than 0. Therefore, it is minimum. That's what they've told here. It is minimum. So with this, we've come to the end of this particular topic. If you've liked the video, do press a like and share it. Thank you.